Hey guys, what's up? Eddie Aho here with KissAnalog.com, and we have Fosse in the lab as a kind of an example of what we're talking about. We're going to talk about monoblocks versus stereo. Okay, a question came up in the comments. Somebody wants to biamp their speaker. They want to know how to hook that up. So I thought we'd talk about the monoblocks, the biamping, and bi-wiring. Okay, so let's just jump in this thing. What's the deal? Well, in a stereo, you have Class A, Class AB. You're probably going to have a big box with heat sinks on either side. And so you have a channel, like left and right channels. And they're separated. So you got good separation. But you got a big transformer in the middle, usually, with some big bulk capacitors and some bridge rectifiers. Okay? And that's how the power supply, sits, is right in the middle, generally. Okay? Well, because of the wiring and everything, you could get some crosstalk. The power supply could, exchange information from one side to the other side as it's changing with the loads. Okay. Now, in a smaller box like this is a ZA3 Fosse. This guy can be a stereo, but it can also be configured as a mono. Okay. So now we have this V3 mono. Now, one set of inputs, one set of outputs. There's an XLR. They're close proximity to each other. They're pretty close. So now with these Class Ds, they have that TPA 3255 chip, which has been used in a lot of amplifiers. It's a really nice chip. Some Class ABs will have a chip amplifier. And when you have a chip amplifier, your left and right channel are both coming out of that chip. So that's pretty close proximity. Now, some Class D amplifiers, have just more discrete circuits. They're separated like a Class A, Class AB. So you find all types. But these are common. And the price is low enough that I think more people are interested in doing monoblocks. And it's a nice way to get more power. Okay. But let's just talk about that. If you have, say, 4-ohm speakers, then maybe you want to get a mono block. Now, let me just talk about the difference or what happens when you take a stereo and you convert it to mono, which this one's already been done. And because it has been, it's more efficient use of space. And so, this has a volume knob. It's going to have some circuitry in there, take care of that. But it also has the left and right channels, and it has different, more inputs and outputs and stuff. So it's a little bit larger for all that stuff. But there's still the TPA 3255. So how does that work? How do you get a mono and a stereo? And how can this be configured as mono? That TPA 3255 actually has like 4 amplifiers in it. And if you tied one end of the amplifier, each of those to ground, you'd have some kind of power out of each one. Okay. But to get more power, what they do is they bridge them. So they take 2 outputs and they tie them together. Okay. So essentially you get 4 transistors, and let's say this guy and this guy down here turn on and the current goes this way. And then these 2 guys turn on and the current goes that way. So the speaker is hooked between these 2 transistors and these 2 transistors. So when you turn these 2 guys on, it goes down through the speaker and down to ground, well, to return on this side. Okay. So these 2 black things are not ground. They're returns for the 2 different channels. They're not the same. You don't want to tie them together, right? They're different. They're like if you have 2 transistors, they're in the center point, there's 2 transistors, so you'd short out transistors. All right, so when you have the 2 channels in this guy, and then you parallel them together, then you got 2 bridges, but it's parallel bridge, okay? So now you got more power. Now, here's the thing is, let's say you had that 4-ohm speaker. Some people talk about the dampening factor, right? And in fact, I heard this one audio file. I went and did some research because I thought, well, people have already probably beat this dead horse. But I thought after listening to them, some of these audio files not to knock them, but they're probably not engineers, a lot of them, and they don't really understand. They know a lot of tech talk, but they don't really have a deep understanding of what all that stuff is. For instance, this guy that really loves tube amplifiers, I guess he talks a lot about that it's not the power, it's dampening factor. Well, that's an example. The dampening factor and power go hand in hand, okay? So you have to have low dampening factor on a high power amplifier. Just works out that way. That's how you get a low dampening factor, is to have power. So when you take these two outputs and tie them together, the output of each one was, let's just say at 1 ohm, just make the math easy. Well, the dampening factors is, you can look at it like the resistance of the speaker divided by the resistance of the amplifier. It's a ratio of those two things. As the power leaves the amplifier and goes in the speaker, some of it is lost on the amplifier, some of it's lost on the speaker. Most of it, you want most of it going to the speaker. So you want that ratio to be really large. Well, if you tie those two amplifiers in parallel, let's just say, like the math was, to make the math easy, you had 1 ohm and 1 ohm. Now you got a half ohm. So you get half the output impedance that you had. And that's the trick, guys. All these things we're talking about has to do with impedance, which is combination of resistance, the reactance of the capacitors, reactance of inductors. So combining that all together is impedance, Z, instead of R or X's for those reactances. All right, so just get that out of the way. So what we want is really low output source impedance, right? So, and that goes for your preamplifier feeding your amplifier too. The output of your preamplifier, you want low source impedance. You want the impedance of the output of the preamp to be very low compared to the input impedance of the amplifiers, which these are very high. So that's usually not an issue. But I just kind of want to mention that because that's the beauty of the XLRs. So when we're talking about all this impedance stuff, the XLR on your amplifier input, you have like a plus input and a negative input. And that feedback loop comes into the negative input, but so does one of the pins of your XLR. So you have your plus and minus, and they go into the plus and minus pins of your amplifier, okay? On the RCA connection, one of those pins would be tied to ground, and your RCA connector, as it plugs in, the plus goes into plus side of your amplifier, and the ground goes to ground or return or whatever. And then those returns are tied together because the one side of the one input was tied to return. But with the XLR, you have some impedance, resistor, maybe a little small RC, going into the plus terminal, and you have the same thing going into the negative terminal, okay? So it's a balanced input, and it's a better impedance factor, okay? So now you have impedance on both pins that are matched, all right? So, okay, so monoblocks, you get separation of things. Things aren't so co-located, where they can induce couple things into each other. And you also lower your output impedance of your amplifier once you bridge it. So this guy comes that way. He's all designed internally like that. And so that's what he's set up. So there you go. So now you have better control over your speakers, and you don't have these things coupled together. Now in a Class A, Class AB, the power supplies are going to be inside that big box, that stereo box, right? And so when you make it a mono, now you have one power supply feeding one amplifier, one power supply feeding another amplifier. The beauty of these Class Ds, these little small guys, they come with bricks. Now you're separate, you're because that whole coupling issue and that, well, now you take your power supply and you decouple it from your amplifier. So now your amplifier should be a lot cleaner, right? Because this guy is removed. Any possible coupling from your power supply. Okay, so And the beauty of that is you have this cable. DC power comes up into your amplifier. So this guy can sit in the back of your rack or on the ground somewhere. You know, if it were to be noisy, the output's going to be clean DC coming up to this. So what you have coming up here running by your connections is going to be a nice clean DC signal. That's awesome. The other beautiful thing is the AC plug that would normally go into a metal box. You would have a third pin, that ground pin, which would be tied to the metal. Well, that is kind of a dirty, noisy place, the ground. All the EMI filters from all these have capacitors going to that little green thing, and they're all tied together. So you have all this noise floating around that's been filtered out of your power supply or out of the power supply rails, you know, your receptacles. So it filters both ways, the filters in these things, right? And they have those capacitors to chassis. So ground is not a clean place. It's a noisy place. It's where a lot of noise is being dumped into. So not having that third pin is beautiful. You don't have that either, okay? So now this guy's isolated from your other stuff. All right, so there you go. So monoblocks, that's pretty nice. A lot of isolation, lower output impedance, beautiful. Power supplies and these Class Ds are separated too. That's also beautiful. So another thing I heard brought up a couple times by different people, they didn't really understand. They were honest. They didn't understand it, but the power supply has modulation on it. And that can couple from one side to the other side. Well, let's look at a stereo amplifier. Let's say the left channel is playing some deep bass music and it's pulling current off those big bulk capacitors. So the power supply has a transformer where you get isolation from input to output. They're magnetically coupled, but they're isolated, okay? Electrically isolated, all right? So that's beautiful. But then you go through a bridge rectifier and that converts the AC into DC, and the capacitors store the DC voltage. Well, those diodes, they're commutating, turning on and off as the sine wave comes into them. It converts it to a pulsating DC. If you took out the capacitors, it just looked like a pulsating DC. With the capacitors, after a few cycles, it turns into a nice straight DC. Once you start pulling current off, then there's some ripple on them. They charge up, then they discharge, charge up, and they do it at 60 hertz in the United States, or actually 120 once you go through all the diodes. It doubles the frequency. And other places it'd be 50 hertz, and it'd be doubled to 100 hertz. So that's low frequency, right? All right. Now, those caps are charged. They have this normal ripple from a load, like say a nice DC load. But an amplifier is not a DC load. It's got music, dynamic power. So as say a bass note gets hit several times, it starts pulling current off those capacitors. And then on the input side, it's trying to charge them. On the output side, it's pulling it down, okay? So they're modulating. That's what's called modulation. The output power is doing this to the ripple, and the input's trying to charge it, you know, at 100 hertz or 120 hertz, okay? So when the voltage comes up on the sine wave and the voltage on the capacitors is a little bit lower, as soon as the voltage comes up above whatever's on the capacitor, it turns on a diode. And whatever diode gets turned on, there's a big pulse of current to pump that voltage back up, and then the diode turns off, okay? So, and then the voltage, you know, the sine wave starts to drop down, and the next diode gets turned on. So that's called commutation. So there's diodes are pumping current and pulses, and it's bang, bang, you know, it's noisy. So that's a low frequency switcher. I know people have called the power supplies and audio amplifiers linear power supplies, but they're not. They've lied to you. Those are low frequency switchers. Now, there are some amplifiers that do have a linear regulator, which would be a transistor or some device you'd put between the capacitors and your amplifier. Well, you might have some capacitors your linear regulator, and some more capacitors. That'd be likely the setup, okay, the topology. So the voltage on this side, as it's doing this, the ripple, you choose a voltage just below that ripple so that there's always a voltage drop across your linear device. That way it can always maintain a nice DC steady voltage on your output, nice stiff voltage. So that's going to turn into some heat on that regulation device, right? And so that'd require more heat sinking and all that stuff. You have to have higher voltage on your output. So many power supplies in the audio amplifier world don't use linear regulators, so they're really just low frequency switchers in that case. In the audio world, where you have the old, heavy power supplies, there's going to be the low frequency switcher types, and then there's going to be the types with that are actually linear power supplies. Okay, in the switching world, you always regulate, so you're not going to get a lot of modulation from the load. You're going to get more ripple, maybe. It's high frequency, and it's going to fill up the smaller capacitors really fast as the frequency is going along, because it's super fast. It's at least 1,000 times faster, okay, as far as the switching, okay? So some advantages: you can hold a stiffer power supply rail with a regulated output, and with a linear regulator, you get a nice smooth voltage. With the switcher, you're going to have little ripple. So if the voltage rails, say you have plus, say, 60 volts and minus 60 volts, or whatever it is, plus minus 80 volts, whatever you have. Well, if the amplifier needs to swing up to, say, plus minus 55, you're going to have some margin between the top of your waveform and where the voltage rail is. So in the switcher, you're going to get this little ripple, so you're going to have some margin in there, so you're fine, okay? If the waveform gets too close, then it flat tops, right? That's not good. So let's say you have a Class A B, Class A amp, whatever, and one channel is flat topping. It's pulling the current down, so maybe it's almost flat topping. Then you get a mid-frequency pulse, something around 3 kilohertz, 5 kilohertz, and it comes up and it wants to go high, but the power supply has been kind of sucked down during this bass note, and then it hits that. So what they say is, if you get 2 monoblocks, get 2 of those amplifiers, then you're not going to have that problem, because now you have more power for each speaker, which is true. But you still don't know if you're going to have that problem, because that amplifier wasn't designed well. So you got kind of a crummy amplifier. So don't go buy another crummy amplifier. Go buy a good one that doesn't modulate with your output. Get one that has the right amount of ripple, that it never comes down into, this margin. So you always have a margin between what this guy's doing and where you want to swing your signal to your speakers, okay? But yeah, so on a stereo, the left channel can be pulling power off that power supply, since they're shared power supplies, and the right channel might not be able to get to do what it wants to do without flat topping. But even once you make that a mono output, you can still have that issue. If you're drawing enough power, you can still have that issue. So that's why I say it's kind of a crummy amplifier. So it needs to be designed right, so that you're not modulating your power supply rails into your signal. All right. Okay, guys. So that covers a whole mono. That covers a whole bunch of stuff. Let's talk real fast about the biamping. So biamping is a speaker that has 4 terminals. You have 2 terminals, you can't biamp. If you have 4, then you'll have 2 pluses and 2 minuses. You have a pair of inputs, and there'll be a shorting bar or shorting wires or something shorting the 2 pluses together and 2 minuses together. So when you run the single red and black to those 2 pairs, they're all shorted together over there. So the 1 red goes to the 2 reds on your speaker. But now if you want to biamp it, you get 2 of these guys for your right side, 2 for your left side. So one of these would go to one set of the terminals, the other set would go to the other set of terminals, okay? So here's the thing with that. is, let's say that speaker is an inefficient speaker, or your amplifiers are just a little undersized. Well, if you change it, imagine if that speaker is 4 ohms. And then once you separate them, it's like you have 2 resistors tied together that make 4 ohms. So once you separate it, the 2 resistors are higher than 4. Let's say they're both 8 equal. Then tying them together would give you 4. They could be different combinations, but they're going to be higher than 4 for sure. So now this guy doesn't have to drive as much current because the impedance went up. Plus you have 2 of them, so double bonus, right? So your impedance, the output of this, driving the speaker, the impedance of the speaker just went up, just probably doubled. So now the dampening factor looks a lot better. It's about power. Now you got more power because you got that ratio, you're improving it, right? But here's the trick with that. These power supply, like this one's a 48 volt brick, 5 amp, and it pretty much maxes these out, not quite, but pretty close. So with power, let's say you have 8 ohm, 12 ohm, speaker, you need more voltage to get the same power as you do in a 4 ohm. So 4 ohm, you just need current. So paralleling all the, using that TPA 3255 in its max setup is going to provide the max current, okay? But in either case, whether it's stereo or mono, you only have this 48 volts to drive, okay? So you're limited on voltage. So as your resistance goes up, it might not be as much power. It depends on how much signal you're trying to swing, because you can only swing so much. So you have to listen to it to see if a single mono or biamping works better for you, okay? So there's that. Now here's the other thing, by wiring. So you have those 4 terminals on your speakers, same as you need for biamping, you need for by wiring. But then what you do is you run, say, a set of speaker cables from your amplifier output, okay? And you run them to one set of those terminals. Well, then you get another speaker wire. So maybe the next one has to have spades, and you put them on here, and you run that cable over to the other set of terminals. All right. So once you've done that, now you've got separate wires for each set of terminals. So now those guys are shorted together up here, but they carry separate current, different current to each one of those 2 sets of terminals. One belief I've heard that people have is that, you have high frequency music, you have low frequency music, and the low frequency music can get in the way of the high frequency. So the high frequency music wants to get by the low frequency, and you're on a highway and it's like those fast cars trying to get by you, and it's a mess. So you give more lanes, and then they can separate and go the way they want to. So that's a bunch of hogwash. It doesn't work that way. It's silly. It's tech talk, audiophile talk. It's not science, okay? The current's flowing the same speed, all right? So as at least amplifiers, all flowing the same way. And if you just use one set of cables to those terminals and short the 2 terminals, as it gets there, the crossover tells which current to go which way. So as you need more current, let's say I have a couple of faucets, a woofer one and a tweeter nozzle, okay? As the woofer, I need more bass sound. I turn up that one and it pushes a bunch of water through my cable, a bunch of juice, right? And then my tweeter does, and I'm like, oh, okay, push that. Well, all that stuff travels together at the same speed, and then it hits the crossover, and whatever needs to go to the tweeter goes that way, whatever needs to go to the bass or woofer goes that way, okay? So it's like electrons are teeny and they're very fast, and there's like tons and tons of lanes in that wire for it to travel. So it'll find its way there. as long as you have big enough gauge wire. That's a trick. So here's another part of that snake oil I've heard is there's a cable, and it's not as expensive as some of the other cables, but it's expensive. And what it is, it's a big cable, and inside it has 2 reds and 2 blacks. And as it comes up, it breaks out into 2 red terminals and 2 black terminals. So it makes it easy to hook up to your speaker. And then you can bring it up in your amplifier with, they're combined as one set. Well, if whatever world these people live in that believe this stuff, if that was the truth, you wouldn't want all the high speed and low speed stuff to be in the same cable coupling together. You'd want them separate. So you wouldn't want to do it that way. You'd want to have 2 separate cables, and you'd want them to run a few inches away from each other. But you don't have to worry about that because things don't work that way. But it's just funny how the one thought doesn't work with the other thought, and they're both wrong. Anyway, so the other thing I heard from an audiophile was that when you run the 2 cables, they have to be identical cables. That's not true either. If it did matter, I mean, in their world, if all that stuff was something that was real, then the one set of cables, it depends on how those 2 terminals are set up in the speaker. If one set is meant to carry the high frequency stuff because it's going to a tweeter, mid-range or something, and the other set's going to the woofer or the subwoofer, the bass speakers, then the ones going to the mid-range and tweeter, they don't carry as much current, so they wouldn't need the same size of wire. And so it makes no sense. So that, having identical wires made no sense at all. It's like if you have 12 lanes on the freeway, if you have 6 and 6, so they're identical, good, put them together, you got 12 lanes. But if you have 2 and 10, you still have 12 lanes. It doesn't matter. It's just how much copper you have between your amplifier and that speaker. That's what matters. So, all right. So hopefully I covered the bi-wiring nonsense. The only thing that matters is to have a nice big cable. Okay. And then what else we got? And then we have the bi-amping. I think we covered that. So yeah, it's awesome. When you're bi-amp and all that stuff, that you're changing the impedance of the speaker versus the amplifier, so it could behave differently. So it's an interesting test. I'm really curious if any of you guys have done that, especially with like a ZA3, like hooked it up and as a stereo or even as a monoblock, and bi-amped the speaker maybe with 2 of them versus a single one, or if you've used them as monoblocks. Leave your comments below if you guys have experimented with that. I'm really curious because I want to experiment with this stuff. So, all right, guys. Hey, thanks for watching. 2 big thumbs up to my YouTube members. 2 big thumbs up to my Patreons. Hit the like button down below. Like the video. Hopefully you found it useful. And that's a free way to support the channel. Subscribe if you haven't done so. That'd be an awesome way to support the channel. And if you think you're subscribed, just double check. Look down. It says subscribe. For some reason, I've heard they unsubscribe people. I've had some people tell me they've subscribed 2 or 3 times. So I want to grow the channel. Appreciate your help. Thanks for watching, and we'll see you next time.